Alright, in this video we're going to be talking about how to solve linear word problems. We're using algebra to solve word problems. So first, let's go over these steps. When you get a word problem, one that's not even on here that I'm going to include is read it, look for anything that's important, circle and highlight anything that you find that's important. After that, define a variable. So if it doesn't say let x be whatever, then you're going to define it, say what this variable represents. Translate the word problem into an equation, solve it, and then give an answer. But when we give our answer, it needs to have units. It needs to say what exactly we were solving for. So we're going to do a few of these together in this video. Well, together-ish. I'm doing it for you. Anyway, for this first set of problems, we're looking for two numbers. We're finding two numbers. So for number one, the larger of two numbers is 4 more than the smaller number. If the sum of the numbers is 74, find the numbers. So I'm going to go through and I'm going to highlight anything I found that was important first. 4 more than the smaller number. Sum. And then, of course, 74. Right? 4 more than. More than is adding. Sum is also adding. So that's all I know so far. That I'm adding, there's a sum of something, and I know the sum of it equals, so I should have really highlighted this word is, because is means equals 74. So now let's define some variables. Let's say I want L and S to mean the larger number. I'm using the hashtag or the pound symbol for number, and the smaller number. Okay. So we know that the larger number is, so I didn't highlight that word either, but there was another is 4 more than the smaller number. So that's what I know about the larger number. I know the sum of whatever the larger and the smaller numbers are going to give me 74. Well, I don't know what the small number is at all, so I'm going to just put that as S. And I know that the larger number, the only thing I know about the larger number is this right here, that it's 4 more than the smaller number. So I'm going to put that in here, 4 plus S, since that is what L is. These are S's, not 5s, I know they look like it. And then I'm going to rewrite it. So I have 4 plus S equals 74. So this part was my L. I'm adding S, and whatever this equals should be 74. I'm going to get rid of these parentheses now. Well, now I have an equation, and I can solve it. I can combine these like terms. Now I have 4 plus 2S. Trying to make it look more like an S. I don't know if that made it better or worse. And I can solve this for S. So to get S by itself, I need to get rid of 4 on both sides. So I have 2S equals 70. And I'm going to divide both sides by 2. So S equals 35. Right? So if S equals 35, Then I can put S back in here. To find L. So I can say my large number is 39, my small number is 35. These didn't really have units, but if I wanted to write it as a sentence, I could do that. Looking at example 2, it's really the same thing. It's just solved, or the setup is a little different for L. Same thing for 3. Number 4 is actually different, so let's do that one. The larger of two numbers is 1 more than 4 times the smaller number if the sum of the numbers, I'm sorry, I'm doing number 3 instead of number 4. Try again. The larger of the two numbers is twice the smaller number. Then it says if 12 is subtracted from the larger number, the result is 7 more than the smaller number. And I think there was an is in there. Okay. So again, I'm going to go ahead and label these S and L. What I know about L, twice the smaller number. So I can say that's sum 2S. If 12 is subtracted from the larger number, so if I have L and I subtract 12, it says the result is, or this should equal, 7 more than the small number. So more than is adding, subtracted from. Okay. So we have our equation, but we have different variables. So let's do some simplifying. First, we know that L is the same thing as 2 times S. So I could replace L with 2S. If I replace L with my 2S, now I only have one variable, and it looks a little easier to solve. Because now I have variables on both sides, I need to get all of my variables to one side and all of my constants to the other. So from here, I'm going to go ahead and subtract this S to the other side. And then I'm going to add 12 to the other side. So 2S minus S gives me just 1S. These cancel. 7 plus 12 gives me 19. And S minus S disappears, becomes 0. So when doing that, I was able to find my value of S. Then I can go back and put that value of S in for L. And figure out that L equals 38. So the concept was kind of the same, but we solved it a little differently. Great. I was going to do 5, but I just realized it's kind of the same thing that we were doing before. It just now talks about the highest score and the lowest score instead of the larger number and the highest number. So those would be the same, solved the same way. So we're going to move on to the next one. So number 6, go through, read this, highlight anything that's important. Garrett has $1 less than 3 times as much money as Liz has. Together, they have $179. Then it's asking, how much money does Garrett have? So our variable needs to be something we don't know. So looking at this, we don't know how much money Garrett has or how much money Liz has. So those are going to be my variables. Let's do lowercase g. And I'll do the cursive L. So this is going to be the how much or the amount of money Garrett has. So this is me defining what this actually means. And then L is going to be the amount of money Liz has. Okay. So now, going back to the problem, Garrett has $1 less than, that means subtraction, 3 times, we're going to multiply. So $1 less than is that turnaround phrase, so 1 has to go at the end. So let's start this process. Garrett has $1 less than, so we know we're going to subtract 1. 3 times as much money as Liz has. We don't know how much money Liz has, but we know it's a variable L, and we can multiply that by 3. We also know however much Garrett has, if we added it to however much Liz has, we'd get 179. So it's kind of like the first problem we did, but a little different. So when I am filling out these blanks, I don't know how much money Liz has, so that's going to stay L. The only thing I know about Garrett's amount of money is this problem right here. So I'm going to put that there. And then I'm going to rewrite it. So I'm running out of space on my page, so I'm going to add another page. So putting it all together, we have 3L minus 1 plus L equals 179. Now we have an equation we can solve. Combine our like terms. 3L plus L will give me 4L. I need to get everything away from L, so I'm going to move the 1 to the other side and add it, and then divide both sides by 4. So L equals 45, so that's how much Liz has. So if we put 45 back into how much Garrett has, remember that was that 3L minus 1. If I put that back in, because the question actually asks, how much money does Garrett have, not how much money Liz has. Because if that were the question, then we'd be done. But we have to put 45 back in and solve. Okay, so then my answers would be Liz has $45. Garrett has $134. So my units would be in dollars. And that would answer the question. Okay. So in reading this, Buffalo Bills scored 24 more than twice the number of points that the Miami Dolphins scored. Altogether, the team scored 66 points, and we're looking for how many did each score individually. So I'm going to say B is the number of points the Buffalo Bills scored, and M is the number of points Miami Dolphins scored. Okay, What we know about the Buffalo Bills, they scored 24 more than is adding twice. We're going to multiply the number of points Miami Dolphins scored. So B equals 24 plus 2 times however many points the Miami Dolphins scored. We don't know that, so I'm going to just put M. We also know that together they scored 66 points. That means whatever the Miami Dolphins scored plus whatever the Buffalo Bills scored. But we know that the Buffalo Bills scored 24 more than 2 times however many points the Miami Dolphins scored. So this would be my equation. I could combine my terms. And then I'm getting M by itself, so subtract 24 on both sides. Running out of space. We have 42 over here. Divide both sides by 3. So if the Miami Dolphins scored 14 points, I could put that back in here to figure out the number of points scored by the Buffalo Bills. So that would be 24 plus 28, which would give me 52, I believe. So I can say the Buffalo Bills scored 52 points, and the Miami Dolphins scored 14 points. Man, that's a tough game. All right, let's move on to some perimeter problems. So with these perimeter problems, again, I'm going to look and see what's important. The length of a rectangle is 5 inches more than 4 times its width. So the length is 5 inches more than 4 times its width. The perimeter of the rectangle is 90 inches. We need to find its dimensions. So what's nice about problems like this is we don't really have to define our variables because it's going to be length and width. So what we know about our length is it is 5 inches more than 4 times its width. So 5 plus 4 times whatever the width is. We don't know what the width is, so we're going to put W. Now, for perimeter, you kind of need to know how to find the perimeter of a rectangle. Remember, you're adding up all the sides. In a rectangle, there are 2 lengths and 2 widths. So you can write your perimeter as length plus width plus width. Or you can write it as 2 times the length plus 2 times the width. Since that is your equation for a perimeter, we know that this perimeter is going to be 90. Then we can start filling some stuff in. So we know that the length is 5 plus 4W. So in parentheses, I'm going to put that in. And then I'm going to continue and solve this. So distribute. So we have 10 plus 8W plus 2W. Combine our like terms. And then go from there. I can subtract 10 on both sides and divide both sides by 10. This is in inches, so I can say this is 8. I think double is inches. Now we need to find the length. So go back, put 8 in for your width. 5 plus 32. So L equals 37 inches. So you can either write it out like that, or you can actually put the word inches. Or you can just put IN, either or. We're just going to do a couple more and then we'll be done. So number 1 is another perimeter problem. So we're actually not going to do that one. We're going to start with, or do number 2. To mail a first-class letter, the U.S. Postal Service charges a flat rate of 53 cents. I keep using this highlighter. And 18 cents for each ounce. It costs $2.69 to mail your letter. How many ounces does it weigh? So a couple things with this. Here, the word flat rate means you're going to get charged that no matter what. So even if your letter doesn't weigh anything at all, they're still going to charge you this 53 cents. Now, I don't know if that's accurate, but they're going to charge you some amount. And then anytime you see the word like for each, these two things are going to be multiplying. So 18 in each ounce. We know the total, and it's asking how many ounces does your letter weigh. So first I'm going to define the variable. I'm going to say Z. You could use O for ounces. I prefer not to because then the O sometimes looks like a 0. And this is going to be the number of ounces that the letter weighs. So from there, I know a flat rate of 53 cents, and I know 18 for each ounce, 0.18 for each ounce. I know that. I know those two are multiplying. Because it says it costs $2.69, and that's the total, I have to add these two things together. To get that 269. I didn't really mean to put that dollar sign, but that's all right. From there, once you have an equation, you can solve it. So this would be 216. And then we'd have to divide both sides by 0.18. We should get that Z equals 12. So I can say 12 ounces. Put my units up there. And then I'm going to do one of the example homework problems, and then we'll be done. So we'll do the first part. No, let's do number 2. So for number 2, a plumber charges $50 to make a house call. He also charges $25 per hour for labor. We have to write an equation that we could use the amount a plumber charges for a house call based on the number of hours of labor. So let's do that part first. Let's also define our variable. So we don't know the number of hours. So to make that equation, it would be 50 to just make the house call. So that's even if they get to your house and they just say, oh, this will take no time at all and it takes like 30 seconds. Then they didn't stay there for an hour and they're not going to charge you another 25. But they did come to your house, so they're going to still charge you that 50, no matter what. But if they do end up staying for an hour or more, they're also going to charge you 25 for each hour. So per hour for each, both of those means multiply. And whatever that would be would equal the total. We could put in the number of hours worked and find the total. For part B, it tells us that, let's say this required 2.5 hours. So we would put in 2.5 and figure out what that would be. So this should be 112.50. Then for part C, it says, now it's giving us the total bill. So it's saying our total was this amount. And we're trying to figure out how many hours he worked. So we're going to put that equation back in. And now we're going to solve for h. So subtract 50 on both sides. And divide by 25. I divided by 25, so h equals 4.5. So 4.5 hours. So sometimes you'll be given an equation and have to find what the total would be. Sometimes you'll be given an equation and you'll be given the total and have to find a variable. It just depends. So now you'll have time to go and practice. Let me know if you have any questions.